Okay, and so today we talk about section 5.4, and we will talk about long division of polynomials here. Okay. But first, let's start out with some basic division. Okay, let's talk about division through prime factorization. So, for example, if we had to divide 540 by 15, okay, well, we can take the prime factorization. Okay, now 540, well, we know that's 54 and 10, and the 10 is 2 and 5. Okay. Now with 54, let's pull that out. 2 goes into 54. 2 goes into 5 2 times with a remainder of 1. Then 2 goes into 14 7 times. Then 3 goes into 27 9. And 3 and 3. So all of these make up this prime factorization. Okay. Come on. Alright, there we go. Alright, so I have 2 2s, and then 1, 2, 3 3s, and a 5 left. Okay. Now down below, we know that the prime factorization of 15 is just 3 times 5. Well, once I do that, I can see that the 5s will cancel and the 3s will cancel, and what I'll be left with is just multiplying these out. 4 times 9, which is 36. So it was very simple once I see the prime factorization. Sorry, this isn't so clear. Let's try this. There we go. Okay, let's try another one. So for example, if we had to divide 210 by 35. Okay, so 210 factors into that. And 35 is just 5 times 7. Now you can see the canceling, and we're left with just 2 times 3, which is 6. So if you know your prime factorizations, dividing becomes very, very easy. Now, we also have long division of integers. Say, for example, if we wanted to divide 178 by 3, well, let's see. 8 and 1 is 15, plus 1 is 16, so 3 doesn't go into this evenly. So we may as well go back to long division. And let's remember how we do this. Okay. So what you're dividing by goes on the outside, okay, and what's in the numerator goes inside. And then we look at it in stages. We'll say how many times does 3 not go into the whole 176, but just in the first 2 numbers. Well, 3 goes into 17 5 times. So we write that up here, and then 5 times 3 is 15, and we would subtract. There's a remainder of 2, and then you bring down the 8, and then we started the process over again. How many times does 3 go into 28? Well, 9 times 3 is 27. So we wrote that down below, and then you subtract the remainder of 1. And so sometimes we'd write it like this, or we'd say that that was 59 and 1 for the remainder over 3. These are equivalent things. So now, let's do the same idea, but using polynomials. Okay. I'm going to leave this off to the side so we can remember where we're at. Let's say we have to take 2x cubed minus 3x squared plus 4x plus 5 and divide it by x plus 2. Now our first step is to set this up as a long division. So the x plus 2 is what we're dividing by, and then it'll go on the outside, and then the numerator goes on the inside. Okay. Now I'm writing this in descending order, 3 to x and then 5. Okay, so if there was something missing, I would need to put in a 0 placeholder. We'll see how that works. Okay. Now the way we're going to do this is the same way that we did long division of numbers. Okay? When we had long division of numbers, we asked ourselves how many times does 3 not go into the entire thing, but into just the first part. So the similar thing will happen here. We're going to look at not the entire polynomial, but just the first part, in just the first part of this. Okay? So these are the dominant terms. Okay? So then what we ask ourselves is how many times does x go into 2x cubed? Well, we can reduce this. This reduces to 2x squared. So just like we've done here, we determined that 3 went into 17 5 times. Okay? So we'll write that up top, and then whatever we write up top, we're going to multiply by and write below. Okay? So we've determined that it's 2x squared. Now 2x squared needs to be multiplied by this entire thing. Okay? Not just the x, but the x plus 2. Now let's simplify that, and as we distribute, this becomes 2x cubed plus 4x squared. Okay. And that's what we write down here. 2x cubed plus 4x squared. Okay. And then what we did here, once we had 3 times 5, is we subtracted the 15 from the 17. Okay. So we're going to have to subtract this. Okay. But remember, when we subtract, we're going to have to subtract the entire polynomial. So what does that mean? Well, that means I have to put the negative through it. Okay. So if I was to distribute that through, it would change the signs to become negative 2x cubed minus 4x squared. Okay. So let's just look at it that way. So minus and minus. Now let's subtract. So 2x cubed minus 2x cubed is 0, and minus 3x squared minus 4x squared is minus 7x squared. Okay. So what we've done right now is 3 goes into 17 5 times, 5 times 3 is 17, and then we subtract it to get 2. Now the next thing we do is bring down that 28, or the 8 to become 28, before we start the whole process over. So let's go again. Okay, bringing these down, plus 4x plus 5. Okay, now we'll start again. We're going to look at x and determine how many times that goes into 7x squared. So that is, we're reducing negative 7x squared divided by x, which reduces to minus 7x. So now that will go up here. That minus 7 becomes a subtract 7x. And then this must be multiplied by this. So minus 7x squared must be multiplied by x plus 2. And then we're going to distribute this through. So minus 7x, I'm sorry, not x squared. Minus 7x times x is x squared minus 14x. So that's what we'll write down here. And then we're going to subtract this polynomial. So remember, to subtract a polynomial, we need to distribute the negative through to get to positive 7x squared plus 14x. So I'll change the signs. This needs to be positive, and this also needs to be positive. And now we can subtract. Negative 7x squared plus 7x squared goes to 0. 4x plus 14x is 18x. And then we'll bring down the plus 5. Okay, now we start the process again. How many times is it that x goes into 18x? So that is, we're reducing 18x over x, which reduces to just 18. Now this is positive, so we write plus 18 up top. And then we'll take 18 times x plus 2. Distributing that through, we get 18x plus 36. And that's what we'll write up here. But remember that we have to subtract it, so we'll distribute the negative. We're going to subtract that entire thing, so that becomes negative 18x minus 36. So this needs to be a negative, and this does as well. Now we can subtract 18 minus 18 goes to 0, and 5 minus 36, well, that's just 36 minus 5, which is 31, but the sign of the larger number is negative, so we'll get minus 31. And so we could write it a couple ways. This is our answer with a remainder of negative 31. We could write it as 2x squared minus 7x plus 18 minus 3 over x plus 2. These are equivalent either way. Okay, now let's see something happen. Okay, let's look at this. What if we had 5x squared plus 3x minus 2, and we divided that by x plus 1? Okay. So this is similar to the prime factorization example. So if we were to factor up top, we'd get 5x and x, 1 and 2, and we have to get to a positive 3, so I need plus 5x minus 2. And then we could just cancel the common factors of the x plus 1, and that would leave us with 5x minus 2. We could do that because x plus 1 is a factor of our numerator, so we're just left with the other. So let's see what happens if we use long division with this. Okay. So x plus 1 goes into 5x squared plus 3x minus 2. And so we'll begin. We ask how many times does x go into 5x squared? That reduces to 5x. So I can put that up here. Now we have to take 5x times x plus 1. And we need to distribute the 5x through to get 5x squared plus 5x. And that's what we write down below here. But we can't, we have to subtract, so we have to subtract the entire polynomial, which gives us negative 5x squared minus 5x. So I need to change these signs to be minus and minus. Now 5x minus 5x squared goes to 0. Then 3x minus 5x is minus 2x. And we can bring down the minus 2 before we start the process again. This time we look and see how many times does x go into negative 2x. So we're looking at reducing this, which just reduces to minus 2. Okay. So that negative 2 becomes a minus 2 up top. Okay. Then we have to take this times this. And when we distribute the negative through, you'll get minus 2x minus 2. Which is what we write up here. But remember that when we are, now we have to subtract, but we have to subtract the entire polynomial, so that means we have to distribute this negative to get positive 2x plus 2. So I need to change these signs to positive 2x and positive 2x. And now, when we add negative 2 and positive 2 go to 0, negative 2, positive 2 go to 0. That means there is no remainder. The remainder is 0. Okay. So this means x plus 1 and 5x minus 2 are factors of 5x squared plus 3x minus 2. Okay. So if there's a remainder of 0, we know they are factors. Okay. Now let's do a couple more examples of the long division. Okay. So 3x plus 2, I want that to go into 6x cubed plus 11x squared minus 31x plus 15. Now notice I've written this in descending order and that every value power of x is represented. Okay. So if I didn't have the x here, like if it was just 6x cubed plus 11x squared plus 15, I would want to add a 0x in here just to help us stay organized. Okay, let's start. Alright, so now this time we're going to look at 3 x's, okay, and ask how many times that goes into 6x cubed. So that means we're reducing this. Okay. So the coefficients reduce to 2, and x goes into x cubed, x squared times. Okay. So that's what we write up top, 2x squared. Okay. Now 2x squared has to be multiplied by this, 3x plus 2. To get 6x cubed plus 4x squared. So this is 6x cubed plus 4x squared. Okay. But then we're going to subtract. So remember that subtracting will change the signs. So this needs to become minus, and so will become this. Now we subtract. This goes to 0, and 11 minus 4 is 7x squared. And now we can bring down the rest. Then we start the process over. 3x goes into 7x squared. Did I do something right? Wrong? Just making sure here. How many times does 3 go? 3 goes in there, 2x squared. 6x cubed plus 4x squared. And then we change the signs. Okay, this is not going to be pretty. Okay, well, we can do it. Alright, so how many times does 7, okay, for 7, how many times does 3x go in there? Okay. Now in this case, the coefficients aren't going to reduce, so we have to just leave that as 7/3 x. It's positive, so it'll be a plus 7/3 x. Now we're going to have to be very careful with this so we don't make mistakes. 7/3 of x times 3x plus 2. Okay. So let's distribute these. I'm just going to distribute right now so we can see any canceling that occurs. And I'll write 2 as 2 over 1. Okay. Now, the 3's will cancel, so we're left with 7 times x, which is 7x cubed. I'm sorry, x squared. Okay, so that will right there. Plus, now there's nothing to cancel here, so this is just going to be 14/3 times x. Okay. Now we're going to have to subtract. Okay, so that means we'll change the signs. And the 7x squared minus 7x squared goes to 0. Okay. Now let's get a common denominator off to the side here, because I'm going to have to take 31 and minus 14/3. Okay, so minus 31 over 1 minus 14/3. Okay, well, if I multiply by 3 and by 3, this is negative 93/3 minus 14/3. Okay. So I'm negative and more negative, that's minus 107/3. Minus 107/3. Okay. Minus 107 over 3x. Whew! Good thing we're almost done. Okay, now let's add 15. Okay. Alright, now we look at 3x plus 2 and how many times that goes into negative 107/3. Okay. We want to divide that by 3, which is 3 over 1. Okay. And remember, when you're dividing fractions, you have to invert and multiply. So this is negative 107 over 9. Whew, okay, we can do it. Minus 107 over 9. Okay. Now we take this times this. I'm going to write this a little bit larger down here. Negative 107 over 9 times 3x plus 2. Okay. We're going to distribute this through. Get minus 107 over 9 times 3 over 1x plus negative 107 over 9 times 2 over 1. Okay, just putting them right next to each other. Now let's see if the canceling will occur. Okay, so 3 goes in here once and in here 3 times. So we get negative 107. I'm sorry, I should be using a different color. Negative 107 over 3x plus, and then there's no canceling here, so 107 times 2 is 214 plus a minus 214 over 9. Okay. So that is just rewriting negative 107 over 3x, and this plus and minus become minus 214 over 9. Okay, so that's what's going to go here, minus 107 over 3x minus 214 over 9. Okay, but we have to subtract that, so remember that's going to change the sign. So this will be plus and this will be plus. And then these will go to 0. And we just simply have to add these two. Okay, so let's scratch that over here. 15 plus 214 over 9. Okay, that's times 1. Getting a common denominator, I need to multiply by 9. Okay. 15 times 9. 9 and 5 is 45. Carry the 4. 9 times 1 is 9. Plus 4 is 13. Okay. So this is equal to 135 over 9 plus 214 over 9, which is, let's see, 135 plus 214, 394, or 349 over 9. And I'm not going to worry about reducing that and even figuring out if it does. Okay, so that will be our remainder, 349 over 9. Good Lord. Okay. All right, let's do another one and see if it doesn't get that complicated. Okay. Now, let's take 4x plus 5 and divide it into 16x cubed minus 12x squared plus 20x minus 3. All right, let's begin. We ask how many times does 4x go into 16x cubed? Okay. 4 goes into 16 4 times, and x goes into x cubed, x squared times. Okay. So that comes up here. And then we take this times this. 4x squared times 4x plus 5. And then distributing this through, with 16x cubed plus 20x squared. So that goes up here. But remember, we're subtracting, so we need to change the signs. And now 16 minus 16 goes to 0. Negative 12 minus 20 is minus 32x squared. And then we'll bring down the rest. Okay. Now we start again. 4x minus 32x squared. So minus 32x squared, how many times does 4x go into that? Well, 4 goes into negative 32, negative 8 times, and x goes into x squared x times. Okay. So this negative 8 becomes subtracting 8x, and then we'll have to take this times this. So negative 8x times 4x plus 5, distributing this through, is negative 32x squared minus 40x. Then that goes up here. But we're subtracting, so let's change the signs. This needs to be a plus, and this needs to be a plus. Now negative 32 plus 32 goes to 0. 20 plus 40 is 60. And then we'll bring down the minus 3. And then we start again. 4x goes into 60x. So we're reducing this. Okay, so see how many times 4 goes into 60. 4 goes in there once, minus 4 is 20, and 4 goes into 25 times. So 15 is what we get here. 15 is positive, so we write a plus 15 up top. Then we have to take 15 times this. And distribute the 15 through. 60x plus 75, okay, which is what goes here. But we have to change the sign since we're subtracting. And then 60x minus 60 is 0. And negative 3 minus 75 is negative 78. So this has a remainder of negative 78. Okay. So I hope you can see through all these examples that we've done that there is a process that happens for each step, and it just keeps repeating itself. And when things keep repeating itself, it's an algorithm, and this algorithm really is only based upon the coefficients here. That's really how it just changes from time to time. So there is a shortcut to doing long division. Now the thing about shortcuts is they don't always work, okay? So it's best to know how to do it both ways. Okay. And it's best to use synthetic division. Well, I'll show you one. Okay, we'll do one more, and I'm going to do long division style so you can see how the synthetic comes out. Okay. This is 2x cubed minus 3x squared plus 4x plus 5. Okay. I'm just going to run through this one very quickly. Okay. X goes into 2x cubed, 2x squared times. 2x times x is 2x cubed. 2 times 2 is 4x squared. Okay. But I want to change the signs. Okay. This will go to 0, and this becomes negative 7x squared, and then we bring down the 4 and the 5. So off to the side here, just pulling out the coefficients here. There's a 1 here, so we don't worry about that. 2 is on the outside. Then there was a 2, a negative 3, a 4, and a 5. Okay. So the only thing I worked with on this side was that I subtracted 2 and then I subtracted 4. Okay. Now I'm going to bring this down, and what I'm left with then is this goes to 0, so there's a negative 7 here. Okay. And these just come along for the ride, the 4 and the 5. Alright, now let's start again. X goes into negative 7x squared minus 7x times. Just making sure. Okay, so then this becomes minus 7x squared minus 14x. Okay. But I'm subtracting, so I want to change the signs. So this goes to 0, and this becomes 18x, and then we can bring down the 5, plus 5. Okay. So the numbers that changed here is that I put a positive 7, a positive 14. These added to become 18, and now we have 5. Not 185, the 5 is separate. Okay. Then we go again for plus 18. So we get 18x plus 36. But I'm subtracting, so I want to change the numbers. and minus 5 is negative 31. Okay, so negative 18 went here, minus 36 goes here, and what we finish up was negative 31. Okay. Now, if we just look at this, then that means we can actually start a synthetic process, okay? And it's a little bit different. If we did this this is a good candidate for synthetic division because of two things. This is linear, okay? There's no like x squared or anything here. And the leading coefficient is 1. Okay? Those are the best candidates for using synthetic division. Okay. So the way the synthetic division works is that you're going to take these coefficients, just like we put here, and they'll go up top. Okay. And synthetic's going to be even shorter than this. Okay. And over here in the box, I put what's over here. Okay. But remember, if I was to solve x plus 2 equals 0, really the x that we're talking about is negative 2. Okay. And so that is what belongs in here. Okay. That also takes care of our subtracting problems here. All right. Now the way this works, in synthetic, you bring down the first one. Okay. Now everything we're going to do is multiply and add. Okay. So we take this one times negative 2, which is negative 4. Okay, so this times this goes here. Now when you add, you'll get negative 7. Then you take this times this, which is positive 14, and then you add, which is 18. So see, we've brought this one, here's our positive 18. Okay. Then 18 times negative 2 is minus 36, and when you add, I always draw a little box here, you get minus 31, which is what we have there. So we've performed the algorithm, and now notice what we have. Here's the 2 that belongs to the x squared, the negative 7 that belongs to x, and the 18, which is the constant. I draw this little line because that's the remainder. Now, because I was dividing by something linear, and I started with x cubed, even if I hadn't done the long division, I would just know that since this is x cubed, this answer has to be 1 degree less. So it's 2x squared minus 7x plus 18 with a remainder of 31. Because I'm dividing by an x and this is an x squared and they're 1 degree off, this has to be 1 less. Or I'm dividing by a linear into the x cubed, I'll get an x squared. Okay, let's do another one. So, for example, if we have x minus 3, and we're trying to divide 5x squared minus 3x minus 36. Okay. This is a good candidate to use synthetic division on, because this is linear, and the coefficient here is 1. Okay. So I bring down the coefficients here. Here's an x squared, there's minus 3. Now, by the way, if I was missing this, I'd have to fill in a 0 here. Okay. Minus 36. And then remember, the number I write in here is if I was to place this equal to 0, then x would be equal to 3. So I write a positive 3 in there. Okay. And now we can start. You bring down the 5. Then you take 5 times 3 is 15. That gets added there. And we add negative 3 plus 5 is positive 12. And then we take 12 times 3, which is 36. And then when you add, we get the last number will be the remainder, and the remainder is 0. Okay, but what's our answer? Well, here is where we're going to find our answers. This was an x squared, and I divided by an x. So this must be linear, and this is 5x plus 12. The remainder of 0. which means that 5x minus 3 is a factor of 5x squared minus 3x minus 36. Okay, let's try it again. Let's say we want to take x plus 2, and that will go into 4x cubed plus 10x squared minus 6x minus 20. Okay. So we pull the 4, the 10, the minus 6, and the minus 20. So 3, 2, 1, and none. So we're okay with that. We take the opposite of this sign, which is minus 2, and we begin. 4 comes down. 4 times negative 2 is negative 8. Then you subtract. So 10 minus 8 is 2. Then 2 times negative 2 is minus 4. And then you can add. So that's minus 10. Then minus 10 times minus 2 is positive 20. Negative 20 plus 20 is 0. The last number is the remainder. Since the remainder is 0, we see that x plus 2 is a factor of all of this. And how many times does it go in? Well, if this is x cubed, then this has to reduce to an x to the 4th. So 4x squared plus 2x minus 10. The remainder is 0. Okay, let's do one more. Say, for example, we had x minus 1. We wanted to know how many times this goes into negative x to the 4th, negative 9x to the 4th, plus 10x cubed, plus 7x squared, minus 6. Okay. So I bring down the coefficients. This is negative 9. This is 10. This is 7. But notice I'm missing the 0x here, an x term, so I'm going to fill in a 0 for that. And then the minus 6. We'll take the opposite of this. Okay. Now we begin. Negative 9 comes down. Negative 9 times 1 is minus 9. 10 minus 9 is 1. 1 times 1 is 1. 7 plus 1 is 8. 8 times 1 is 8. 0 plus 8 is 8. 8 times 1 is 8. Negative 6 plus 8 is 2. This remainder is not 0, so x minus 1 is not a factor to this. Okay. But it does go into this whole thing, negative 9, now this is x to the 4th, so this has to be x cubed, plus x squared plus 8x plus 8 with a remainder of 2. Should we do one more? May as well. Okay, example. Alright, this time we want to take 3x to the 4th plus 18x cubed minus 3x plus 40 and divide that by x plus 7. Okay, so we'll pull out the coefficients, 3, 18. Now notice I'm missing the x squared, so put in a 0, then minus 3 and 40. Remember, this is solving x plus 7 equals 0, so x is equal to negative 7, so that's what belongs here. And now we begin. Bring down the 3. 3 times negative 7 is negative 21. 18 minus 21 is minus 3. Minus 3 times minus 7 is 21. 0 plus 21 is 21. 21 times 7 is minus 147. Negative 3 minus 147 is minus 150. 150 times 7, 0, 35, 1050, and that will be positive. So our remainder is 1090. Yeah, okay. And so what does this represent? This represents 3x cubed minus 3x squared plus 21x minus 150, and we have a remainder of 100, or 1090. Okay, so that's long and synthetic division. Get comfortable with using them and just how to perform long division and synthetic division. We'll be using them, these tools, in our next chapter. Email me if you have a question.